All right, 7th graders, we are now in section 6.4. So here's my question for you. What's slope-intercept form? Hopefully you said y equals mx plus b. Today we're going to learn a second form. This one is called standard form. Now, slope-intercept form, which you've already learned, is just one form of a linear equation. Another form is called standard form. This is actually useful in making quick graphs. So here's your key concept. Standard form. You must memorize this. ax plus by equals c. ax plus by equals c. Repeat after me. ax plus by equals c. A, b are the coefficients of x and y. C is a constant. Now, a, b, and c are all real numbers. A and b cannot be both 0. If they were both 0, you'd have something like 4 equals 7. So a and b can't both be 0. One of them could be 0, but not both. All right, now I actually think this is almost more important than your key concept. This is how you're going to graph using x and y intercepts. Now let's think about it. The y-intercept you already know. The y-intercept is where the graph does what? Crosses the y-axis. The x-intercept is going to be the same thing. Where does the graph cross the y-axis? So in this problem, you can use the x and y intercepts to make a graph. The x-intercept is the x-coordinate of a point where the line crosses the x-axis. To graph a linear equation in standard form, you can use the x-intercept. Here's how you find it. To find the x-intercept, you're going to substitute in 0 for y and solve for x. Now to find the y-intercept, you're going to substitute in 0 for x and solve for y. So your key concepts are right here. To find the x-intercept, substitute in 0 for y. To find the y-intercept, substitute in 0 for x. So in example 1, I want you to find the x and y intercepts. So find the x and y intercepts. So let's do two problems. Problem A, find the x and y intercept of 3x plus 4y equals 8. Now, to find the intercepts, remember, this is in standard form. It's important to understand that if it's not in standard form, put it in standard form first. So, ax plus by equals c. To find the x-intercept, this is something that I would expect you to do at the end of this lesson without much work. But I'm going to show every step on the first problem. To find the x-intercept, you're going to plug in 0 for y. And then you solve the equation for x. 4 times 0 is 0. You get 3x equals 8. My x-intercept is 8/3. So my x-intercept, I don't like leaving it as x equals 8/3. I like writing it like this. Your x-intercept is 8/3. You could also say the ordered pair would be 8/3, 0. Or you can just say x-intercept is 8/3. To find the y-intercept, I'm just going to erase this. We already have it. To find the y-intercept, I plug in 0 for x. So now you just solve the equation. That gives you 4y equals 8 and y equals 2. Therefore, my y-intercept is 2. What does that mean? That means that this graph would cross the x-axis at 8/3 and it would cross the y-axis at 2. Example B, 5x minus 20 equals 2y. Now in this equation, it's not in standard form. So we have to have the x term first. We do, 5x is right there. But then we need the y term. So how do we move a plus 2y? We subtract it. How do we move the minus 20? We add it to the other side. This is a step you should be able to do completely in your head. So this is going to be 5x minus 2y equals 20, and that's in standard form. This is where that I would expect you to be able to do a lot of this in your head. If I plug in 0 for negative 2y, that's going to give me the equation 5x equals 20. 5x equals 20, I'm going to get x equals 4. Now, if you needed to show the work, you can do that. To find the x-intercept, I'm going to plug in 0 for y, which means I'm just going to get the equation 5x equals 20. I solve, I get x equals 4. So my x-intercept is 4. Now, if I plug in 0 for x, that gives me the equation negative 2y equals 20. Divide both sides by negative 2, that gives me the value of x equals negative 10, and that gives me the y-intercept of negative 10. So my x-intercept would be 4, my y-intercept would be negative 10. In the next example, we're going to go one step further and graph once we find those intercepts. So let's do another equation. Let's have the equation 2x plus 3y equals 12. On your own, I want you to find the intercepts. You can do them completely in your head if you want, but find the intercepts on your own. Now, if you solved for the intercepts, you would have gotten 2x equals 12, so the x-intercept would have been 6, and the y-intercept would have been 3y equals 12, so the y-intercept would have been 4. So our intercepts would be 6 for the x and 4 for y. So then when you graph this, now notice what I did is I magically had a graph up here. But I'm going to label my x and my y. Always label your x and your y. And then you just graph. So the x-intercept is 6. That means it crosses the x-axis at 6 and the y-axis at 4. So then you connect your line. Always use a straight edge or a ruler or something along those lines to make a straight line. Otherwise, you end up with a line that looks like mine, which I can't use a ruler on an iPad. But make sure you always use a straight edge, put arrows at the end. The one other thing we're going to do, your book does not cover this, but every time you graph from now on, you must tell me the domain and range. In this case, domain is the possible x values. Now, you'll get better at this. If you just have a line with arrows at the end, it will always be all real numbers. Your domain, since your x, if you look here, your x values only go left or right. This graph continues to the right, it continues to the left. Therefore, your domain, the x values, are all real numbers. Your range, same thing, up and down. This graph continues to go up, it continues to go down. Your range, which is your y, is also all real numbers. All right, B, you can either pause the video and skip ahead and graph it yourself to see if you get the same thing, or you can follow along with me. Step 1. Put it in standard form. Standard form means I'm going to get rid of the subtract 2y by adding 2y to both sides. So standard form would give me 5x plus 2y equals negative 10. Now if I graph this, we first find the intercepts. My x-intercept, now once again, if you wanted to show the work, you can. But your x-intercept would be 5x equals negative 10, because the y term we plugged in 0 for. That gives me an x-intercept of negative 2. And a y-intercept, if I get rid of the 5x, 2y equals negative 10. That gives me a y-intercept of negative 5. So if I graph this, on the x-intercept it crosses at negative 2. And on the y-axis it crosses at negative 5. And my line would look like that. My domain, since it's a line and it goes left to right, it's all real numbers. My range is also all real numbers. Now, when you graph horizontal and vertical lines, let's graph the equation y equals negative 3 and b x equals 2. When you graph horizontal or vertical lines, you're going to either have a vertical or horizontal line depending whether or not you have a y equals or an x equals. Vertical and horizontal lines happen when one of the variables is 0. It doesn't exist. So, for example, in part A, y equals negative 3, that means it's going to cross the y-axis at negative 3. So, we can put a dot, the intercept, 0, -3, but you're going to have a horizontal line. Y equals, always have horizontal lines. So this is y equals -3. And x equals 2 means it crosses the x-axis at 2. So this is x equals 2, and y equals -3 is below. The second thing we're going to learn is writing equations in standard form. We kind of went over that through the first set of examples. But what happens if we're given something in slope-intercept form? So let's say we have the example, y equals 3/4 x plus 2. And I want to write it in standard form. First off, you got to have whole numbers as your a, b, and c. Or integers, I'm sorry, integers, not whole numbers. But y equals 3/4 x plus 2. Step 1, we're going to multiply everything by something to get rid of our fractions. So the first step is you can change an equation from slope-intercept form to standard form. If the equation contains fractions or decimals, multiply to write the equation using integers. So the first thing I'm going to do is, since I have a divide by 4, I'm going to multiply by my least common denominator of 4. That gives me the equation 4y equals 3x plus 8. I then have to move the 3x to the other side, and that would give me -3x plus 4y equals 8. Now let's try another one. You can pause the video and do this yourself if you would like. Y equals -2/5 x plus 1. To get rid of the divide by 5, we can multiply by 5. That gives me 5y equals -2x plus 5. We move the 2x over, and I would get 2x plus 5y equals 5. In example number 5, it says, write an equation in standard form to find the minutes someone who weighs 150 pounds would need to bicycle and swim laps in order to burn 300 calories. But we're going to take this a step further. Not only do I want you to write an equation, I'm going to make you interpret the intercepts, I'm going to make you tell me the domain and range, and I'm going to make you graph it, because I'm mean. So in this problem, let's first set it up. X I'm going to let be the number of calories per minute, or the number of minutes for bicycling. Since X is bicycling, Y would have to be swimming laps, the calories burned per minute. So Y is going to be the number of minutes spent swimming laps, and X will be the number of minutes spent bicycling. So our equation is pretty easy to set up. 10 calories per minute of bicycling plus 12 laps of swimming, calories per minute of swimming, equals a total of 300 calories. So my equation is 10x plus 12y equals 300. The next step is going to be to graph it. So what are our intercepts? Find that yourself. What's the x-intercept? 300 divided by 10, it's going to be 30. Y-intercept is 25. Now, when we graph this, make your graph, but remember, this has to be only in the positive quadrant. So we only need to graph quadrant 1. So, I made it smaller, but the x-intercept is 30, y is 20. So we draw our quadrant 1, x and y. We have to label our axes. X is the number of minutes bicycling. Y is the number of minutes That's really bad. Let me actually make that nicer. All right, so number of minutes spent swimming. We start at 0. Now remember, you can count by whatever you want. I'm going to count by 5s. 5, 10, 15, 20, 25, 30. And then on the y-axis, 5, 10, 15, 20, 25. Now my y-intercept is 25. My x-intercept is 30. I'm going to connect that. Now let's talk about the domain and range. Your domain, the values of x. What can the values of x be? And this is what I love. I love how this works because this makes you think and understand your graph. What's the lowest x value that we have? It's 0. What's the highest x value you have? 30. You're not going to go over 30. You're not going to go less because the number of minutes bicycling, we want to burn 300 calories. If you go farther, we're burning more than 300. So our graph stops at 30. So our domain has to be between 0 and 30. And as it looks here, we can write it as a conjunction. X is greater than 0 and x is less than 30. X is between 0 and 30. Now my range is y. What's the lowest and highest range? Well, the y value goes from 0 to 25. So, and here's how you get that. If you can't look at the graph and see what that is, plug in 0 for x. What's the y value when x is 0? It's 25. What's the y value when x is 30? It's 0. So we know the y value has to go from 0 to 25. Now let's interpret our intercepts. This means tell me what the 30 and the 25 mean. The y-intercept is 30. This means, this is important that you can interpret this. The x-intercept means that this person, a 150-pound person, spent 30 minutes bicycling and 0 minutes swimming. So what does the y-intercept mean? The y-intercept means that this person spent 25 minutes swimming and 0 minutes bicycling. Because the intercept, x-intercept 30, that's the point 30, 0, so y is 0. Here, x is 0, so therefore you spent 0 minutes bicycling.